Okay, now once we've done all the hard work and we've gotten this into a form where it's completely factorized, so this is just a bunch of blank numbers, you might say that pretend that a is not there. You just have three sets of brackets because it's a cubic, so like x to the power of 3. You'll have at most three sets of brackets. You might have an a out the front, which is just like, when you have 3x squared or 4x squared, that 3 and that 4 is just going to make it skinnier or wider or whatever. So once I have it factorized, I've done all the hard work, I've used long division, I've used either the remainder or the factor theorem, and I have it in a factorized form. Now I can draw it. So you'll remember that when we did things like this, parabolas or quadratics, it was kind of hard to graph it unless it was factorized. So we factorized it first, then we found x-intercepts. So we'd say like x minus 2, x plus 1, and then we say the x-intercepts were 2 and minus 1. And then you get your graph and you plot them 2 and minus 1, and then you just had to determine whether it was this way or this way. And the way that you did that was you'd look at the original thing and you'd say, oh, is that positive? And if it was positive, then it was a smile. And if it was negative, it was a frown. It's going to be exactly the same thing. Okay, so let's go through this one. What I want to do is, you'll notice also that here I only have two sets of brackets, but I've got this x out here. You can think of this x as, so if I rewrite it, you can think of this x as like x minus 0, maybe. Maybe that's a little bit more confusing, maybe not. Okay, so then if I want to sketch this, the easiest way to sketch a parabola was to find its x and y intercepts, which is the easiest way to sketch anything really. So I'm going to find the x and y intercepts. So I'm going to say x-intercept, which means I make y equals 0. So then I've got 0 equals x outside of x plus 5 instead of x minus 1. Okay, that means x is equal to 0. Now you've got to be careful because there's this one here as well. It's quite easy just to go, oh, minus 5 and 1, but this is here as well. So x equals 0, x equals minus 5, and x equals 1. So then my three x-intercepts. I can find my y-intercept as well. So y-intercept, I make x equals 0. So when I make x equals 0, that gives me y equals 0 outside of, and the rest doesn't really matter because I'm multiplying by 0, but I'll write it anyway. Okay, so that's 0. And now I just start drawing it. So I'm going to put my graph here. Be careful about it. Okay, so x equals 0 and y equals 0, so that's there. X equals minus 5, we'll call that there, so minus 5. And then x equals 1, let's call that there. Okay, so kind of the skill in here is determining how the hell I'm going to draw this thing given all these points. Because it's a cubic, that means it turns 1 less than the power it is. So with the parabola, it's x squared. It turns once. In other words, it looks like this. That's where it turns. With an x cubed, it can turn twice. So in other words, it could... the cubics we saw were kind of like this, right? But when it's complete like this, you'll find that they'll either look like this, so they turn twice, or the opposite way, so like this. So you've got to think about how on earth can I draw this thing such that it looks like that. So one way you could do it is like this, or like that. Okay, obviously you're not going to be able to find these points, but that's what calculus is for. So you just got to determine which way it's going. And the easiest way to do that is if you expand it all and your x cubed term is positive, then it increases, so it looks like that. Whereas if it's negative, it looks like that, so it's like decreasing. A different way of doing it is sometimes what I do is like just think about where my points would be over here. So if the graph looked like this, if I put like minus 10 into my equation, then I think that I would get a value down here, right? But if I didn't, I got a value up here, then maybe my graph looks like this. So there's heaps of different ways of doing it. So maybe I'll write them down. The first way would be to just like choose values. So like choose extreme values. They're called end values. Maybe I'll just call them that. So end values. So it's called checking the end behavior. So the behavior of the graph at the ends of the graph. So like here and here. So if I found a point up here, it's going to be like that. If I found a point down there, it's going to be, so I already said that. So, for instance, negative 10 and 10, like for example. The second thing you can do is x cubed positive or negative? yeah. So I know that x cubed, if you were to expand this, your x cubed term is going to be positive. So that's one thing you can do. And so my graph's just going to look like this. Wow, I'm really living life on the edge here, 5%. Okay, and that's it. Like, that's as far as we can go. Yes, these points and this point would have some sort of symmetry, and so would this point. So that's something you could take into account when you might consider what that coordinate is. But at the moment, we don't have the tools to be able to really find these. Especially, like, we can find their x value, but I suppose we can find the y value, but don't really have to do that. All I want you to be able to do is find x and y intercepts and then figure out what the graph kind of looks like. Because it's, at the end of the day, it's just a sketch. Sketch doesn't have to be accurate. I don't need points like a plot. But that's it. I don't want to spend too long in this video, but I just want you to think about all the different things that you can do in order to determine the shape of this thing, in order to sketch it.